So in other words, we're going to be given some zeros here. Okay, well, let me just start. I'll start out here with this. And then here's our first example. Zeros of 1, -1, and 2. Okay. So we're looking for a polynomial that's going to have of least degree, right? So that means you want to make it the lowest degree that we can, okay? We're not trying to have, we're not trying to make like these ridiculously high degree polynomials. We're trying to make it as small a degree as we can, okay? Rational coefficients, so rational numbers, or those are just numbers that can be written as fractions, like 1/2, 1/3, those kind of things. So there shouldn't be any like square root of 2 or pi's in our polynomial, anything like that. And a lead coefficient of 1, okay, lead coefficient of 1, and zeros of 1, -1, and 2. So what we're going to do here is essentially work backwards from what we've been doing, right? What we've been doing is we've been given a polynomial and asked to find the zeros, right? Now we've got the zeros, we want to work backwards and come up with a polynomial that would result in those zeros. Okay? So these zeros then, right, these numbers right here, they're going to make our function f of x equal to 0. Okay, right? If it's a 0, that means when you plug 1 in, or you plug -1 in, or when you plug 2 in, you get 0 as an answer. Okay. So in other words, that's like this, right? Those are our answers, right? Those would be our answers. When we have our function equal to 0, these are going to be our answers. So then, if x equals 1 is an answer, okay, what is a factor that would give us this answer? Not just 1. What is a factor that would give us this answer? What's that? Okay, so x minus 1, right, equal to 0. Right? And so there's our factor. Right? So we subtract 1 from both sides here, so that's equal to 0. And we get x minus 1 equals 0. That's one of our factors. Okay? What factor would give us x equals -1 as an answer? X plus 1. X plus 1. Okay? So again, we're just adding 1 to both sides there, so it's equal to 0. Okay? And then finally, what factor would give us x equals positive 2 as a factor, as an answer? X minus 2. Exactly right. Okay? And so we have our 3 factors. And so we're going to multiply then. We're going to take these and we're going to put them together. Okay? Right? Because isn't that what would happen in reverse, right? Normally, we have these 3 things multiplied together. They're equal to 0. We then set each one of them equal to 0 and then solve, right? Well, now we're going to put them back together to create this polynomial. Okay? Right? Technically, at this point, we're done. We've written the polynomial. Okay? But we're going to put it in standard form, which means we have to multiply this out. Okay? We're going to multiply this out. All right? So I'll multiply the first 2 things together here. All right? So again, x times the x times the 1, minus 1 times the x, minus 1 times the 1. So x times x will give us x squared. X times 1 will give us 1x. Minus 1 times x, minus 1x. And minus 1 times 1, minus 1. Okay. Again, the x minus 1 doesn't have to multiply to the x plus 1 and the x minus 2. It only multiplies with one of them. So I chose to multiply it with the x plus 1 there. You could do x minus 1 times x minus 2. But you don't want to do it to both. Okay? Don't multiply the x minus 1 to both things here. Okay. Now let me simplify in here. Okay? The plus 1x and the minus 1x, right, goes away. So we're left with just x squared minus 1. And we got x minus 2 equals 0. Okay? And then we'll multiply this back together here too. So x squared times x squared times minus 2, which gives us x to the 3rd minus 2x squared. And then minus 1 times x is minus 1x. And then minus 1 times minus 2 plus 2. Okay? And so here is our function. Okay, well, just put a whole answer. Just wrote right through it, but anyway, you get the idea, right? There's our polynomial. Right, there's our answer. This polynomial would give us those zeros. This polynomial here would give us the zeros that we were looking for. Okay, that's all there is to it. Questions on any of that so far? So far, so good? Okay. So, of course, right, we had other kinds of zeros, though, than just these, nice integer numbers, right? So, for example, what if we have zeros of 3 and 2 plus or minus the square root of 5? Oops, off the screen. There we go. Okay. Okay. What if we had these as zeros, right? What would we do here? Well, again, we're going to take these answers. So we have x equals 3 as one of our answers, and we'll have x equals 2 plus or minus the square root of 5 as another answer here. Question? Yeah. Okay. So what factor gives us 3 as an answer? X minus 3. Okay, that one's easy enough. So there's one of our factors. This one's a little bit tricky here, but it's not so bad. Again, we'll do the same thing we kind of did here where we subtracted 3 from both sides, so it's equal to 0. We'll do the same kind of thing. I'm going to subtract a 2 over. Okay, so the 2's cancel. We have x minus 2 equals plus or minus the square root of 5. Okay, but then at this point, I want to eliminate that square root. Okay, because again, we want to have rational coefficients here. And so we don't want to have any irrational numbers. Square root of 5 is irrational, right? It's a decimal that goes on forever, never repeats, all right? And so we got to eliminate that square root. Well, now that we have that square root by itself, what could we do to this side to eliminate the square root? Yes, square both sides. We have to square both sides, of course. Okay, now I held off. I did not square at first because the 2, right, was not underneath the square root. So I didn't want to square my first step here because the 2 was not square root of 2. So I wanted to bring that 2 over first before I then squared both sides. If you square both sides at the start here, you're not going to eliminate your square root. Okay, it won't work. But if you move the 2 over first, then you square both sides, now that square root will eliminate. Okay, now when you square x minus 2, remember that means you're multiplying x minus 2 times itself. So I'm going to rewrite that like this. Okay, and then this, what is plus or minus root 5 squared? What does that result in? What's the square of plus or minus root 5? Not plus or minus 25. It's just going to be 5. Because again, a square cancels out a square root, right? And so I can just write that as a regular old 5. And it doesn't matter. The plus or minus kind of goes away. If I square a positive number, it's positive. If I square a negative number, it's positive, right? And so I end up with just plain old 5. If you don't believe me, you can type this in your calculator. Okay, if you don't believe me, which is fine. It's a good thing to question, right? Just to make sure. All right, so square root of 5, squared is 5, but also negative square root of 5 squared is also 5. You see? So either way, if you have the plus root 5 squared or the minus root 5 squared, they both become 5. All right. And so then I'm going to go ahead and multiply this out. So I get, again, x times minus 2, so x squared minus 2x, and then minus, or plus 4, I should say, equals 5. Okay. I'll combine like terms here, so I get x squared minus 4x plus 4 equals 5. Okay. I'm almost done with this factor, but again, for a factor, I need it to be equal to 0. So what do I need to do here to still be equal to 0? We've got to subtract 5 from both sides. Exactly right. Okay. When we subtract 5, whoops, I didn't mean for that to cancel, but oh well. Minus 1 equals 0. Okay, so here is our other factor. So this is one of our factors. This is our other factor right here. Okay? And so we're going to multiply these two factors together then to get our answer. So x minus 3 times the x squared minus 4x minus 1. Okay. Technically now, this is our polynomial. This is our polynomial that will yield a 0 at 3 and a 0 at 2 plus or minus root 5. Okay. But again, we're going to put it in standard form, so we're going to multiply it out. Okay. So it'll be x times x squared, x times minus 4x, and x times minus 1. So the x to the third minus 4x squared minus x, and then, bless you, minus 3x squared, and then minus 3 times negative 4 plus 12x, and then minus 3 times negative 1 plus 3. And we'll just combine any like terms. So let's see here. I've got the x to the third, minus 4x squared and minus 3x squared minus 7x squared, and then plus. Yep. There we go. Okay. All right. Questions on any of that? We're going to do one more here together, and I'll have you guys try one. Okay. We'll do one more together, and then I'll have you guys try one here. Okay. So again, we've had different scenarios for our zeros, right? We've had, of course, zeros that are just, nice integer numbers. We've also had zeros that were integers, but then we also had some irrational stuff too, right? Like that. We've also had imaginary zeros, right? So let me show you then what it would look like when we have imaginary zeros. Okay. So I'll do one down here. Okay, so if we have a zeros of, let's say, 2 and plus or minus 3i. Okay, 2 and plus or minus 3i here. Okay, so x equals 2 is one of our zeros, and x equals plus or minus 3i is one of our zeros too. Right? Again, same kind of situation though. This is going to be just like number 2. If you follow along with number 2, okay, you should be fine for number 3 here. Okay, what factor would give us an answer if x equals 2? X minus 2, right? Okay, so there's one of our factors. For this one, okay, I don't want to just bring this 3i over because I is imaginary. How can I get rid of an I though? Remember, what does I mean? It means imaginary, and what number does it represent? The square root of negative 1, right? So if I want to get rid of the square root of negative 1, I'll just square both sides again. Okay? Right, think about it this way. This is really plus or minus 3 square root of negative 1. So I can just square this. Okay, I can just square that. Okay, x squared will just be x squared, right? What's 3 squared? Well, what's plus or minus 3 squared? A positive 3 squared is going to be what? And what's negative 3 squared? Just 9 again. Just 9 again. Because negative 3 times negative 3 will be positive 3. What's I squared going to give us? Or in other words, what's the square root of negative 1 squared going to be? Just negative 1. So we'll have 9 times negative 1, or just negative 9. Okay? But again, to have my... Sorry? Yeah. Yeah. I mean, if you can just see it, absolutely, you can just like rewrite it if you need to. Nope. If you can just see it, yep, do it. Yep. Okay? Now, remember, our factor needs to be equal to 0. Right now, I have x squared equals negative 9. So what do I need to do to make this thing equal to 0? Not subtract. Add 9. There you go. Yeah. Add 9 to both sides. Okay? So we get x squared plus 9 equals 0. Okay? So there's our other factor. And so we're just going to multiply x minus 2 times x squared plus 9. Okay? And that will yield our polynomial when we multiply it out. Okay, that will yield our polynomial when we multiply it out. Question? Yes. All right, so we'll multiply this out, right? So again, x times the x squared, x times the 9, minus 2 times the x squared, minus 2 times the 9. So we'll get x to the third plus 9x minus 2x squared minus 18, right? X times the x squared gives us x to the third, x times the 9, 9x, negative 2 times x squared, negative 2x squared, negative 2 times the 9, negative 18. And this is not quite in standard form, so I'll rewrite it one more time so we have them in descending order. And there is our polynomial. Okay. Questions on any of that? So, just a couple things here, right? Before I give you guys one to try. Actually, you know what? I'll give you one to try. We'll go ahead and have you guys try one here. All right, so here's yours to try. All right, so I want you, again, to come up with a polynomial that has zeros of 4 and 1 plus or minus the square root of 5. Okay. So go ahead and come up with a polynomial that has the zeros of 4 and 1 plus or minus the square root of 5. I'll do that too here real quick. Question? Sure. Yes.
So with the 1 plus or minus the square root of 5, you square both sides.
You want to get the one, move the 1 over first. You want to isolate the square root first, then square both sides. So move the 1 over first. How do you want to try this? Okay, put you this way too. You don't need that out right now, okay? So it's probably just a distraction. You gonna be okay going on your own? Need any help? Let me know here. Again, just come up with your factors, right? So you have a 0 at 4. What's your factor then? Okay. You got a 0 at 1 plus or minus root 5. Okay, so come up with the factor then that would yield that. You got it?
Yeah.
So yeah, subtract the 1 over first from here. Then square both sides. So have x minus 1 or x minus 1 quantity squared.
Mr. Whitmire, can you check my work since
Yep. Absolutely.
that's where I'm at right now.
Okay. So this I think this should be a minus 1x here.
Okay.
Because x times x equals x squared, x times a minus 1, minus 1x, and then minus 1 times x, minus 1x, and then
Okay.
minus 1 plus 1. So you should have minus 2x in the middle
Okay.
there. And then you don't need to plus or minus anymore either, because when you square this plus or minus root 5, if you square a positive root 5, it's 5. If you square a negative root 5, it's also
Okay.
going to be 5. So the plus or minus goes away too. Okay. Okay. So here's as far as I got. Alright. So if x equals 4 is one of your zeros, right, then that means x minus 4 is a possible factor. Okay? It does not mean that x minus 4 has to be the factor. I'll explain that in a second. But x minus 4 is a possible factor that would give you a 0 at 4. Okay? Here for the 1 plus or minus root 5, we'll subtract the 1 over. So Geo, here's what I was talking about. And you just want to check to make sure. So I subtract the 1 over, right? And then I have plus or minus root 5 equals x minus 1. I square both sides here. So I get just a 5 there. X minus 1 squared, remember that is x minus 1 times x minus 1.
Now I see what I did wrong.
Okay, so yeah, there you go. Okay, and that's what I wanted you to see. So thank you for looking. All right, so x minus 1 times x minus 1 is x squared minus 2x plus 1. That's equal to 5. Okay, I'm just going to subtract that 5 over, so it's equal to 0. So we'll have minus, no, x squared minus 2x minus 4. Okay, equals 0. And so there's our other factor, and so we'll just multiply the x minus 4 with the x squared minus 2x minus 4. Okay, and again, we got to distribute, right? So it's going to be x times the x squared, x times the minus 2x, x times the minus 4. Negative 4 times the x squared, negative 4 times the minus 2x, negative 4 times the minus 4. So we'll get x to the third minus 2x squared minus 4x minus 4x squared plus 8x plus 16. So minus 6x squared plus 4x plus 16. So there's our final answer. Okay? Or there's our simplest answer, I should say. Okay? All right. questions on any of that? I have one more thing I want to show you, and then I'll get you guys started on your assignment, okay? And you should be able to finish, hopefully, before the bell, so that way you don't have any homework this week. Just finish any class. All right, but one thing I want to briefly just talk about, and then I'll show you the last problem I want to do, okay, is this right here, right? X minus 4 equals 0. That is one possible factor that would give you x equals 4 as a 0, right? So x minus 4, that factor, if you solve it, right, will give you x equals 4. But what would be another factor here that would also solve and give you x equals 4? What's another factor we could use? Okay, so besides x minus 4 equals 0, right, that would solve and give me 4. That's the simplest one, okay? Can you think of another factor that would give me 4 when it's equal to 0? What's another factor that would give me 4 when I solved it equal to 0, right? Julian, got an idea? I heard you say 2. Are you saying 2? Okay, 2 what? So what about this? Two x minus 8 equals 0. Does this solve and give me x equals 4 as a 0? It does, right? What about 3x minus 12 equals 0? Does that solve and give me x equals 4 as a 0? Yeah. So there's an infinite number of possibilities here that I could really use for my factors, right? If I want x to be equal to 4, I could use that x minus 4, but also 2x minus 8, also 3x minus 12, okay, et cetera, right? But why do we use the x minus 4? Well, because we stipulated a lead coefficient of 1. Whoops. A lead coefficient of 1. All right? If I have a number in front of my x, that's going to be part of my lead. Darn it. If I have a number in front of my x, like the 2 or the 3 there, that's going to be part of my lead coefficient, and I don't want that. We want a 1. So that's why we keep this simple one here. Okay, and we forget about these other more complex ones that would also work. All right. One more thing I want to look at here, and then we will get you guys yours started here. Okay. Okay, write the cubic function that is graphed below. I'm just going to sketch the graph here. You see I'm putting some points down there too. I'll do the graph in red so it stands out some. So all we've got is this graph. Okay. All we've multiplies the graph, and we want to come up with the cubic function that yields this graph. Okay? How can we know by looking at the graph that this is potentially cubic? What about the graph?
Touches the x 3 times.
Okay, right, we've got 3 zeros. We've got 3 zeros. So, since we have 3 zeros, we know that it has to at least be a cubic function, right? Because degree 3, right? It's got to be at least degree 3. Okay, it's got to be at least degree 3. Okay. And none of them are repeats, so, but anyway. Well, they could be repeats, I guess. Not even, but anyway, yes. We know it has to at least be a cubic. Okay? So, that means a cubic, right, with our 3 zeros. What are our 3 zeros here? What are the 3 zeros we have here?
1, 3.
Okay, 3, 1, and negative 4. Yep. So x equals negative 4 is one of them. X equals 1, and x equals 3 is a 0. Okay? Which means then if x is equal to negative 4, what factor would give us that? X plus 4, right? If x equals 1 is a 0, what factor would give us that? X minus 1, right? And then if 3, excuse me, if 3 was a 0, then that means what factor would give us that? X minus 3. Aha! 1, 2, 3 factors. So if we want to make a cubic, let's just put them together here. Okay? And so there's our polynomial, right? And we might think, hey, we're done. Well, let's check something here. I'm going to graph this polynomial that we think is our answer. All right? I'm not going to multiply it out. I will eventually multiply it out, but for right now I just want to leave it this way just so I can prove a point. Okay? So we've got our 3 factors multiplied together there. I'm going to put it in y1. I'm going to graph it. Whoops, back to my normal viewing window there. Okay. Does that look like the graph that I have right here? Not really, right? My end behavior in my graph here is I should be going down as I go to the left and up as I go to the right. As x goes to negative infinity, right, I should go down. As x goes to positive infinity, I should be going up. But it's the exact opposite here. So is this, or if we graph this, is it this? No, it's not. Okay? It's not. How can we maybe fix this? How can we maybe fix this so that it'll more closely represent this, right? With our end behavior, right, it's the exact opposite. So what can we do here to fix this? Right? Instead of going down to the left, we want to go up. And instead of going up to the right, we want to go down. So what should we do to fix this, maybe? What? A negative. Okay, let's throw a negative in front. Okay? Let's throw a negative in front. So I'm just going to throw a negative in front here. So I'm going to get negative 1 x plus 4, et cetera, et cetera, et cetera. Let's graph it. Okay? Now the end behavior matches, right? But we also have one other point here that we're given. I very purposefully put negative 6 as my 0 here. Or my y-intercept, I should say. Let's see what the y-intercept is according to my table. According to my table, my y-intercept is negative 12. But on my graph, I need my y-intercept to be negative 6. So I need more than just a negative 1 in front here. Okay? Again, with what I currently have, my y-intercept is at negative 12. But I need my y-intercept to be at negative 6. So I need more than just a negative 1 in front here. What else do I need? Right now, my y-intercept is negative 12, and I want it to be negative 6. What do I need to do in front there? Besides just a negative 1, what other number do I need to put in front there? If I want to go from negative 12 to negative 6, what number do I want to put in front there? What can I multiply by to take a negative 12 and make it a negative 6?
6.
1/2. 1/2. I multiply 1/2. Okay? So yes, the number we want to put in front here is a negative 1/2. Okay? Now, If you're sitting there thinking to yourself right now, Mr. Whitmire, how am I ever supposed to figure this out, right? That sounds like, seems like a lot of work, to figure that out. Well, let me show you a different way to think about it then, if you're like, don't want to just like kind of like, wrestle with it a little bit by looking at the graph and stuff. What we can do instead is we'll just put an A in front. Okay? Put an A in front, right? Like our lead coefficient there, they're going to solve for. Okay? Put an A in front. All right? And then we're going to plug in this y-intercept, this other point, okay, right? We already have the zeros taken care of, right? We're going to plug in this point right here. So again, this is the coordinate 0, negative 6. So then the 0 for this point, where would it go in my function? And for what part of my function? 0 would go in where? If I want to plug this point into my function here, where would the 0 go in? For what variable? X. It's an x coordinate, right? So we'll have A, 0 plus 4, 0 minus 1, 0 minus 3. And where do I put the negative 6? It's a y value, right? So where should it go in?
In front of the, right there.
We're going to put it in place of the f of x. Replace the f of x. Remember, f of x is like our y, right? So we're just going to replace that with negative 6. And now we're just going to solve for a. Look, it's an equation. We can solve for a here. So 0 plus 4 is 4. 0 minus 1 is negative 1. 0 minus 3 is negative 3. If I multiply these all together, 4 times negative 1 times negative 3, I get positive 12. So I get 12a equals negative 6. And then what should I do to get the a by itself here?
The A by itself.
Yeah, what's with the a I need to get rid of there? What's with the a that I need to get rid of? 12. Right? We have a 12a. So what do I do to get rid of the 12? Divide. Because it's 12 times a, so we're going to divide. So we get a equals negative 6 divided by 12 simplifies to negative 1/2. Hey, there's the negative 1/2 we needed. So our function is negative 1/2 x plus 4, x minus 1, x minus 3. Hello? Hey. Okay, gotcha. Bye. All right, Mike and Nate, you're wanted in the AP office for literally a minute, so you shouldn't have to take your things with you. Okay, but they want you in the AP office. All right. Yes, sorry, Mike and Nate, yes. All right, so there's our polynomial, okay? So again, get your zeros, all right? Create the factors from your zeros, and then put an a in front there, and just use that fourth point there, the y-intercept in this case, right, to help us then find that a value. And so there's our polynomial that will, in fact, exactly match that. And now if I put that negative 0.5 in front, okay, there's the graph with the negative 0.5 in front. You can see how closely it matches there. Okay? All right. Questions on any of that? All right. So then, your homework, all right, is going to be out of the book. I would like you to do. Oh, that's annoying that they did that. Numbers on page 263.
What section?
Oh, that's 7-2 again. Page 263, 7-2. I'd like you to do numbers 5, 6, and then 10 and 11. Okay, 10 and 11 are word problems again in the same kind of feel as that Sequoia problem that I just showed you how to do. Okay, I want you guys to re-tackle these. Okay, to see if you can get them now. Again, just read them, and it's the same kind of thing as that Sequoia tree problem. 5 and 6, it's like we just did here for the notes. Okay, now I'm going to help you guys out a little bit here. Okay, for number 5. Actually, you know what? I think you should be okay. I still think you should be okay. So never mind. I think it should be okay. All right, so there you go. 5, 6, 10, and 11. All right? Give those a try there. I'll get the video coming right here. I'll come around and help. So it's literally 4 problems. Literally.